Hello, my dear students. Welcome to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 1, Probability, brought to you by Vitan Sir. This is the continuation of exercise 1.2. Carrying off from where we dropped the last time, question number 6. Find the probability of getting R in the first place and M in the last place when all the letters of the word random are arranged in all the possible ways. Okay, let's see. These are the places, the boxes where I'm going to put the words random. You can see 6 boxes here. That means 6 places are there. So 6 characters are to be arranged at 6 places. Whenever we are talking about arrangement, we call the permutation. So 6 characters, 6 places, that means 6p6. That is our total outcomes. That is 6p6 is the 6 factorial. So 6 factorial is 6 into 5 into 4 into 3 into 2 into 1. And when you do it on a calci, the answer is 720. That means our total outcomes, the n is 720. Now moving forward to what is the question given here, that r in the first place and m in the last place. So when r is in the first place, one character at one place will make it 1p1. Similarly, m in the last place, that means one character as one place will make it 1p1. So 2 times 1p1 and the remaining 4 characters at 4 places will make it 4p4. So favorable outcomes here will be 1p1 multiplied by 1p1 multiplied by 4p4. R at first place, M at last place, and remaining 4 characters at any remaining 4 places. So when we solve this, 1 into 1 into 24 will make it 24. So the favorable outcomes here are 24. The n is 720, the m is 24. So the probability m upon n will be 24 upon 720. To simplify it, our answer here will be 1 upon 30. You know 24 3s are 720. So 1 upon 30 is the answer of the probability for question number 6. Moving on to the question number 7. Find the probability of getting vowels in the first, third and sixth places when all the letters of the word orange are arranged in all possible ways. Okay, the characters here are orange, as you can see here, and the respective places are there. Now there are 6 characters and to be arranged in the 6 places will make it 6p6. So once again our total outcomes will be 6 factorial 720. Now the first, third and sixth, the vowels are O, A and E. That means O in the first place, A at the third place and E on the sixth place. Now they have not said that O should be on the first place only. That means these 3 characters could be arranged any way we want in these 3 places. So 3 vowels in the 3 places will make it 3p3. Now you can see the remaining characters R, N and G, and they also have their own 3 places. So once again 3 characters in the 3 places will be 3p3. So for the vowels 3p3 multiplied by, for the remaining characters 3p3 will be our favorable outcomes. So 3p3 multiplied by 3p3 will be 6 into 6, 36. So this is how we solve this kind of sums, that 3 vowels can be arranged in the given 3 places. Now O, A and E could be interchanged with each other, so that is 3p3, and remaining R and G again has 3 places, so again 3p3 makes it 36 outcomes. So the probability will be m upon n, that is 36 upon 720, and when we simplify it, 36 2s are 72, so 1 upon 20. So the probability of question number 7 is 1 upon 20. Question number 8. 5 members of a family, that is husband, wife and 3 children, are randomly arranged in a row for a family photograph. Okay, good. Find the probability that husband and wife are seated together. Okay, now this is something different. How we are going to solve this? These are the 5 places where the family is going to sit. This is husband, wife, children 1, children 2 and 3. First of all, we need to calculate the total outcomes. So total people are 5 and their places are also 5. So that makes it 5p5. The total outcomes will be 5 factorial, that is 120. I hope you guys know what is a factorial here. Okay, factorial means starting from that value, all the remaining values up to 1. That is 5 factorial means 5, 4, 3, 2, 1 and multiply all of these values. 5 into 4 into 3 into 2 into 1. So I guess you guys already know this. Okay. In case you don't remember how it is done, you can revert back to my 11th video about the permutation, combination and binomial expansion. Okay. Now, coming back to our event here, that husband and wife are seated together. It will be something like this. As you can see here, that husband and wife are seated together. That means they are internally exchanged, but together they create a single big box. Okay, so husband and wife, I have grouped them into a single place because they are going to sit together. No matter where they go, they will keep on being together. That means I can call them a single entity here, and that's why I have put them into a single box. Now I have turned the colors of the singular boxes into red so that you can recognize that okay, husband and wife make a one box, then 3 children add up to other 3 boxes. That means we have 4 red boxes. That means we have 4 groups. First group consists of husband and wife together, so that's one entity, and then 3 children can sit separately, so they are other 3 entities. So total they make 4 entities. So 4 entities to be arranged at 4 places will make it 4p4. And additionally, you can see 2 white boxes. Yes, husband and wife could be interchanged. That means husband can sit first, wife can sit afterwards, or wife can sit first and husband can sit afterwards. So because 2 white boxes are there, I will call it 2p2. 2 people sitting in 2 places. So 4 red box will make it 4p4 and 2 white box will make it 2p2. So our favorable outcomes here are 4p4 multiplied by 2p2. Husband and wife make a group because they are sitting together. So they are only considered 1 in the initial phases and remaining 3 children makes them 4p4. But husband and wife can sit interchangeably. So that makes it 2. So 2p2. So 4p4 is 24, 2p2 is 2. So 24 2s are 48 favorable outcomes. When I put it into my probability formula, 48 upon 120 will make it 2 upon 5. So the probability that husband and wife sit together is 2 upon 5. The ninth question. 7 speakers A, B, C, D, E, F and G are invited in a program to deliver a speech in a random order. We have to find the probability that speaker B delivers his speech immediately after speaker A. First of all, let us write down the places for which these speakers are going to deliver speeches. I have just written them in ascending order. It doesn't matter that they are going to deliver it in this manner, but the total outcomes here, that is 7 speakers delivering speeches in 7 different orders, will be 7p7. So the total outcomes here will be 7 factorial, that is 5040. So there are different 5040 arrangements in which these 7 speakers can deliver speech. But now what we want is that B will deliver speech after A. This makes them a group. So this is how they are going to look like, that they are in a group where B delivers speech after A. Now this box I have made, it might look different from the previous sum where husband and wife were there. The simple reason for that is husband and wife could be interchanged, that husband can come first, wife could come afterwards, and wife could sit first and husband can sit afterwards. But in this situation, the clear-cut instruction is that B will speak after A. That means the only option here is A and B, but B and A is not possible, so they can't be interchanged. A cannot speak in the place of B and B cannot speak in the place of A. B should only speak after A. That's why there is no internal box here, and that means all the boxes here, red boxes are there, no white boxes are there. So only one term will be there. If you count them, the number of red boxes are 6. So the favorable outcomes here will be 66, and we are not going to write down those additional 2p2 outcome here, because A and B cannot be changed with each other. They are fixed, they are rigid, so only one will be there. So 6p6 favorable outcomes will make it 6 factorial, that is 720. So the probability here will be m upon n, that is 720 upon 5040, that is 1 upon 7. You can find certain illustrations related to this particular question in the textbook. If you want, you can refer to them. If you want, you can just rewatch this video for the reference, for the sake of understanding. But remember this, whenever these internal elements are interchangeable, I have shown them in boxes, separate internal boxes. But in this case, A and B are not interchangeable, so they are not in a separate box, rather they are in a single box. Moving on to my personal favorite sum. Find the probability of having 5 Mondays in the month of February in a leap year. Now, you need a basic knowledge of the days in the months, and days in months and the leap years and non-leap years days and all that. You need to have a basic knowledge about that. You need to know that there are 12 months in a year, then each month has different days. For example, January has 31 days, February has 28 days, and March again has 31 days, etc. Then you need to understand that in a year there are total 365 days, but whenever leap year is there, a one day is added, that is 366, and that one additional day is added in the month of February. So usually February has 28 days, but in the leap year February has 29 days. So this is the basic knowledge which you must have. So we will start with the total days in the month of February during a leap year, that is 29. Now we need 5 Mondays, but before that we know for sure that every month in a year, no matter which month it is, they have at least 4 weeks. Okay, weeks, 4 minimum weeks are always there in any month. So we will start with that. Total days in 4 weeks, and each week has one Monday, that means 4 Mondays. So the total days in for 4 Mondays, that is 4 weeks, are 28. Each week has 7 days, so 4 weeks means 28 days, and 4 weeks also means 4 Mondays. Now the question is 5 Mondays. I will get to that now. The difference, the remaining extra day or days, out of 29 days of February, 4 weeks take up 28 days. So the extra day which we have is 1. What we can do with that, that if this day is also Monday, we will get total 4 plus 1, 5 Mondays. 4 weeks are for sure, they are a certain event that 4 weeks are there. But if in this extra one day, if we get a Monday, then we will get 5 Mondays. But this extra one day can have any of the Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. That means the total outcomes for this one day, the total number of different options for this one day are 7. But we don't need all of them. We just need one outcome, that is Monday. So the favorable outcome here is 1. Out of the total 7 different options which could be there for a single day, our option is Monday. So the probability here will be favorable upon total, that is 1 upon 7. So the probability that there will be 5 Mondays in the month of February during a leap year is 1 upon 7. How did I do it? Just rewind this video and you will understand it better. Question number 11. This is again a similar sum. Find the probability of having 53 Fridays in the year which is not a leap year. Now we are not talking about a single month. We are talking about a leap year. Now you should remember that any year has 52 weeks. Total days in the year which is not a leap year are 365, and any year has at least 52 weeks. That's a certain event. So total days in 52 weeks, each week with 7 days and 52 weeks, so just multiply them, you will get 364. Now 52 weeks, each week has one Friday, so 52 weeks will have 52 Fridays. So the extra remaining day which we have right now with us is again 1. So in a year, 365 days, 52 Fridays need 364 days. So the remaining extra day which we have with us is 1. What we can do with this one day, that if this one day is also a Friday, we will get 52 plus 1, that is 53 Fridays. That's the event which we want right now. So the total outcomes once again here will be same. That is, this one day could be Monday, it could be Tuesday, it could be Wednesday or Thursday or Friday or Saturday or Sunday. That means the total outcomes are 7. What we need is only one, that is Friday. That means the probability will be similar, m upon n, that is 1 upon 7. Okay, I hope you guys are getting the point here, the total point here. We are not talking about each and every 365 days. We are just talking about that excess day which could be ours, and using that day we have to calculate the probability. This will be the last sum. It is again a similar sum but a bit higher level. Find the probability of having 5 Tuesdays in the month of August of any year. Now August in any year always has 31 days. It doesn't matter whether it's a leap year or a normal year, it always has 31 days. So total days in the month of August of any year are 31. Once again we have to start with 4 weeks, that is total days in 4 weeks. 4 weeks means 4 Tuesdays are 28, and right now rather than having one day we are having 3 remaining extra days. Okay, so if all 3 of these days cannot be a Tuesday, because we can't get 3 Tuesdays in a row, and these 3 days are in a row. So if any one day among these 3 days is Tuesday, then we will get 4 plus 1 is equal to 5 Tuesdays. So right now we have 3 days in a row. Of course the days will be in a row. So when we talk about the total outcomes here, we have to talk about it like Sunday, Monday, Tuesday, or Monday, Tuesday, Wednesday, or Tuesday, Wednesday, Thursday, or Wednesday, Thursday, Friday, or Thursday, Friday, Saturday, Friday, Saturday, Sunday, or Saturday, Sunday, Monday. That means we have to find out the combination of 3 days among the week which are in a single row. So just imagine that if our week, the 4th week ended on Saturday, then the next 3 days will be Sunday, Monday, Tuesday. Similarly, next 3 days could also be Monday, Tuesday, Wednesday, and similarly we have 7 different options here. So the total outcomes are 7. What we need is a Tuesday, and when you check out this 7 outcomes, you can see that the Tuesday could be Sunday, Monday, Tuesday, it could be Monday, Tuesday, Wednesday, or it could be Tuesday, Wednesday, Thursday. So there are 3 possible outcomes which can give us a Tuesday. So when we put it like that, we get Sunday, Monday, Tuesday, Monday, Tuesday, Wednesday, Tuesday, Wednesday, Thursday. That is 3 possible outcomes which are in our favor. So the probability here will be m upon n is equal to 3 upon 7. Okay guys, I hope you guys got this properly. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.